This video will show how to set up OpenVPN across the internet. Here we have a Linux-based PLC from Wago with an onboard cellular modem and a Wago power supply and Ethernet switch. We'll be using a Raspberry Pi 3 for our OpenVPN server. Before we can start, we need to install a standard GSM SIM card into the Wago PLC. Let's look at the simple networking diagram. Here you can see the Wago PLC connecting to the cell tower, across the internet to the cable modem, down to the Raspberry Pi 3, which is behind a fixed IP address. And we're using a laptop to do the configuration. Start by SSHing into the Raspberry Pi 3, which has already been set up for headless. We need to do a sudo apt-get update and then a sudo apt-get upgrade. This will update the Raspberry Pi 3 with all the latest packages and security updates. Now we're ready to install the OpenVPN server on the RPi. Just type in curl -l followed by this HTTPS link. And this will install the software on your RPi 3. It's a really easy to use wizard. Basically, you just have to make your selections. Just clicking OK here. We are going to be using a static IP address in this case. So we're using 192.168.4.30 as the diagram showed for our RPi 3. We're going to be using the Pi user, and we are going to allow unattended upgrades, which is really nice. If this is in the field, it'll automatically install patches and things over time. We're going to be using UDP, and the port is 1194, which is standard. We want to use 2048-bit encryption. Just keep clicking OK. This will take some time to create the keys, and then it will ask you about your IP address, and you can either use static or you can use a dynamic DNS type service. In this case, we're using static, and then you can choose your DNS provider. We just use Google here. So then we want to reboot our Pi. And we'll just do one more apt-get upgrade just to make sure we have all the latest packages installed. Now we'll create the clients using the command pivpn add. Type your client name followed by the password and a verification. And the keys will be stored in the folder as shown in your home directory, and you need to use FTP to copy those files out, which we'll use to configure your clients. Ideally, your client and your server would be on different subnets. So in this case, we're using a laptop to configure both devices, so we need to have two NICs on our laptop. I'm binding one to a VM and using the host adapter for the Raspberry Pi configuration. So here you can see the 0.133 we're using for this Ubuntu VM. If we use an ifconfig, you can see we're at 0.100 for the VM. So now that we're on the same network, we can use our web browser to connect to the Wago's web-based management. If I click on modem, you can see the status of the radio connection to T-Mobile, and we have 2 bars of signal strength, which isn't too bad. We'll go to the OpenVPN configuration tab and enable VPN server, and then using the browse, we'll upload the client that we created in a previous step and click Start Upload. Now you can reboot your Wago, and we'll SSH into the Wago PLC, and we'll just ping the Raspberry Pi 3 just to confirm that there's no network connection present yet. Now we can open a new terminal window and establish our connection through the VPN tunnel. We'll do this by typing in openvpn openvpn.conf, which is what it renames the file when you upload the client config. Then it'll ask you for the passcode that you use for this client. Type that in. In a few seconds, it'll open up the tunnel, hopefully. Here you can see a sequence is completed, so we'll go back to our other tab and we'll reissue that ping command, and you can see that we're pinging back from the Raspberry Pi 3. I only have 2 bars of signal strength, so I'm getting a pretty slow response here. Hopefully with a better reception on my cell, it will work better. But I hope you enjoyed this video. Found it's an easy way to do VPN connections across the internet. Thanks.